Hello and welcome to our tech tutorial channel. Today we're diving into a fascinating topic for all you automation enthusiasts out there. A PLC programming example focusing on delaying the start of 7 motors. Whether you're a beginner or have some experience under your belt, this video aims to enhance your understanding of PLC programming using a practical and straightforward solution. So, let's get started. Imagine you have 7 motors, and you need to program them so that when one starts, any subsequent motors will only start after a 5-second delay, maintaining the sequence in which they were activated. Sounds challenging, right? Well, thanks to a solution by Peter Steinhoff, we have a clear and effective approach to tackle this using Do-More Designer software. First, let's define our task. We have 7 motors, each connected to a switch. The goal is to ensure that after the first motor starts immediately upon activation, any additional motors will only start after a 5-second delay, preserving the order of activation. Our inputs will be the switches for each motor, all normally open. The outputs naturally are the motors themselves. The key here is ensuring a 5-second delay between each motor starting, following the sequence they were turned on. Peter's solution involves using one timer for each motor, labeled as on delayin, on delayo, and so on, plus an additional down counter timer. This down counter doesn't control anything directly, but keeps track of the time between motor starts. Let's say you want to start motor 4. You would take the current value of the down counter, assign it to on delay 4, and then add 5 seconds to the down counter. If motor 4 is the first, it starts immediately since the down counter is at 0. If another motor is started shortly after, its delay is set based on the down counter's current value, ensuring a 5-second gap. By mapping this out in a spreadsheet, you can visualize the timing and sequence. This method is not only simple but also scalable, allowing for more motors to be added without complicating the logic. Plus, it ensures motors start in the order activated by the operator. After developing the PLC program, testing is crucial, either through a simulator or on actual machinery. This ensures the program runs as expected and allows for any necessary adjustments. To summarize, by using individual timers for each motor and a down counter, we can effectively delay the start of each motor by 5 seconds, maintaining the sequence of activation. This solution is not only efficient, but also adaptable for different scenarios and additional motors. And that wraps up our tutorial on delaying the start of 7 motors using PLC programming. We hope this video has provided you with valuable insights and a clear understanding of how to approach similar automation challenges. If you have any questions or need further information, feel free to reach out. Thank you for watching, and see you in the next video.